So welcome again, and today we're going to continue with descriptive analysis. And so we have this data which is posted. We're going to apply a number of functions so we can get used to them. So to start with, we can actually count how many homes were sold. Here we have 12 homes, we know that, but let's start by counting. Or we can see the number of houses that have been sold, so we will count them. And so you can put equal sign, type count, and so we're going to select count and select all these values, and then you can close the bracket and enter. So you can see we actually have 12. The next thing we can do is to find maximum price. So, or we can find the highest price, and we can put equal sign and type max. And so we can select this function and highlight all these values, close the bracket and enter. You can see that this is the highest value. Actually, this is the one. And then we can find a minimum value, or the list value, or the list selling price. So just put equal sign, type MIN, and then select this function. Select all these values, close the bracket and enter. So you can see this is the lowest price, and we can actually find it is number 5. So when we have maximum and minimum, we can find range. And so range is maximum minus minimum. So just put equal sign, click on the maximum value minus minimum value. So let me repeat again. Put equal sign, click on the maximum value, and then minus, click on the minimum value, close the bracket and enter. So range is this value. So you can see that the highest price and the lowest price differ by this much. So can we say that this is too much or not too much? We cannot say so unless we have more evidence to prove that the range is actually too much or not too much. So we will learn that as we move on. Now we will start first with some measures. In descriptive statistics, we have a number of measurements or number of measures. One is measures of the center. And these measures of the center, we have mean, sometimes we call it average, we have mean or average, we have median, and also we have mode. So let's start looking at mean or average. We can find average from this data by putting equal sign and just type average. So select average and select all these values, close the bracket, and so we know that the average is this. We can also find median. Just put equal sign, type median, and so click on it, select the values and enter. And you can see that the median value or the middle value is this one. So if we need to get mode, you can just put equal sign and type mode, and so select mode and then go to the values, close the bracket, and enter. So this is the value that occurs most. However, sometimes we may have values that will occur, more than one values that will occur more than other values. Let's say if this value occurs twice, we may find another value that occurs twice. And so when we apply mode, Excel function will just pick one value and ignore the other. So in this case, we need to find multiple mode. So call mode. So just select few cells and then don't do anything, just put equal sign and then type mode, and now select mode and select all these values, close the bracket, however don't enter. So hold down Control and Shift keys and then enter. So you can see we actually have two values that occur the same way but more than other values. So here we don't have the third one, and in this case we can just leave it like this, showing that we have only two values. So this one here occurs twice and this one here occurs twice. So these are the values that occur the most. Now you can see we are done with the measures of the center to find average, median mode, and mark mode. Now the second thing is to find measures, variation. So measures of variation are range, variance, and also standard deviation. So we can consider this as the main measures of variation. And remember, we were able to find range where we took maximum value minus minimum value. So in this case, we can put equal sign and click on this particular value. We will refer to this value and enter. So we have range. We have copied this value here. Now next we have to look for variance. Just put equal sign, type VAR, this value here, this function here. So double click it and then select your values and close the bracket. So we have variance. To find standard deviation, you can put equal sign and type STD and just select STDEV, standard deviation, and select all the values, close the bracket, and enter. So you have standard deviation. Now let me show you one thing here. We know that standard deviation is the square root. Standard deviation is the square root of variance. So let's put equal sign here and try to find the square root of this value. So type SQRT, that is the square root. And we want to find the square root of this value. If you enter, you can see we have same values. And also, variance is when you square this value. So let me put equal sign here and click on this value to the power of 2. So that means we are making this value squared. If you enter, you can see variance actually is the same. We can see we have the same values. That's what we learned, that variance is S squared if we have small values, or we can say sigma squared, and standard deviation is just S. So it is the square root of S squared. So we have found measures of variation, which are range and variance, and also standard deviation. We can look at other measures like measures of location. And measures of location means that we are looking at a particular location where the value can be found in the data set. So we have percentiles, and we can also find quartiles, but let's start with percentiles. And so we can go with 25th percentile. And to find the percentile, we can put equal sign and type percentile, and just select percentile EXC, and then select all these values, then put comma sign, and now you're supposed to put K. So here you can see we have selected the data array, and so K is this 25th percentile, so it should be 25%, and close the bracket and enter. So you can see that is percentile, 25th percentile. So let's look for 58th percentile. We'll do exactly the same. Put equal sign, type percentile, and select percentile.exe. Then select all these values, and then that's our data array. Put comma sign and type 50%. So we have this as our percentile. Now let's see what did we get for median, and just put equal sign and click on the median and enter. So you can see that 58th percentile is actually the middle value, or median. Now let's select 75th percentile. So just put equal sign, type percentile, and select the same function. Highlight all the values, close the bracket and enter. We have data array, and we need to put the K, which is 75%, and enter. So we got this value. Now let's find quartiles. So we have first quartile, and then second quartile and third quartile. So our first quartile, I'm going to put them in this side. So the first quartile, just put equal sign, type quartile, and select quartile EXC. Select all the values, close the bracket and enter. So when we select all the values, we have to put the comma sign, and we need to select the first quartile. So just put 1 and enter. Now you can see the first quartile is actually the same as 25th percentile. Let's find the second quartile. Just put equal sign, type quartile EXC, So we're going to select the data array and then put equals comma sign and select the second quartile. So we'll select all these values, put comma sign, and in this case we're going to select 2, which is the second quartile, and enter. And you can see the second quartile is the same as 58th percentile. It is actually the median or middle value, and it is actually the second quartile. Now let's find the third quartile. And so we will select the values, and then we will put comma sign where we will select the third quartile and enter. You can see 75th percentile is the same as the third quartile. Now we will need to, let's find interquartile range. IQR. So the interquartile range, in this case, you will take the third quartile minus the first quartile. So just put equal sign, click on the third quartile minus the first quartile and enter. So that's the interquartile range. We normally use interquartile range to find the length of the whisk. If you're looking at the box and whisker plot. We're not going to do it manually, but we can actually use Excel to find box and whisker plot when we have these values. So why do we need to find box and whisker plot? It's because we want to identify outliers. And with outliers, we will know if this range is too much or it is not too much. So let's do here box, and so we're going to find box and whisker, and we'll plot it. So in this case, we will select these values, and let's insert. You can go to recommended charts and see if we have it here. If you're using Windows, you have this opportunity. You can go to all charts, and you will find box and whisker. So you can select this. Now, if you're using MacBook, you can go to, I believe, statistic. Yes, you go to statistic, and then you will find box and whisker. So you can select it. Now, either way, it will be okay. So let me select this. And so you can see we have this chart. Please label it. Make sure always you label your charts. And also label vertical axis and horizontal axis if necessary. And if you look at this chart, you can see that we have this value, which is actually 45,650. It is considered as an outlier because this is the length of the whisk to the right hand side, and to the left hand side is this much. And you can see that average is pulled by this big value. So average is being pulled to the right by this big value. And so we have right skewed distribution, and this average may not be the right average. So let's try to remove this value, which is an outlier. Normally we remove the outliers. So for now, let's try to remove it and see if average will move closer to the middle value. So let's remove it. Once you remove the outlier, you can see that average is actually at the middle, and so has changed. and it's close to the median value. So as I said, we use box and whisker to identify outliers. And when we have outliers, we should remove them. So what does it mean by this outlier? So you can see these are the price for homes, and we have a number of prices, and they are more or less the same. They are not that much different, except this value, it is too much as compared to other values. So this house was sold a little different, and so we should remove it and compare prices which are more or less similar or more or less the same. And so if you remove this value again, and now you can see even the range has changed. So we can say this range is not that much. However, if we include the same value, you can see the range has increased.